let's begin. So it is my absolute pleasure to introduce Dean Ayanna Howard from The Ohio State University. Now, I need to read this because she has so many awards, I cannot memorize them, so I'm gonna read this. Dr. Howard is the Dean of Engineering at The Ohio State University and the Monte Ahuja Endowed Dean's Chair. She's also a faculty member in electrical and computer engineering and has a joint appointment in computer science and engineering. Before that, she was the Linda J. and Mark C. Smith Endowed Chair in Bioengineering and Chair of the School of Interactive Computing at Georgia Tech. Before that, she was a senior robotics researcher and deputy manager in the office of the chief scientist of NASA's Jet Propulsion Lab, oh my gosh, JPL, let's go with that. She does a whole bunch of research on AI, assistive technologies, and robotics. She has more than 275 peer-reviewed publications. In 2013, because she was bored, I guess, she founded Robotics, an education technology startup. She's a fellow of IEEE, AAAI, AAAS, and the National Academy of Inventors. She received the Anita Borg Institute Richard Newton Educator AB Award, the CRA Nico Haberman Award, the Richard Tapia Achievement Award, the Nesby Janice Lumpman Educator of the Year Award, and the ACM Athena Lecture Award. She serves on the board of directors for Autodesk, Motorola Solutions, and the Partnerships on AI. She's got a whole bunch of press, I'm not gonna even list those, and she's been recognized as one of 23 most powerful women engineers in the world by Business Insider, and one of the top 50 US women in tech by Forbes. On a personal note, I have had the pleasure of working with Dr. Howard in several capacities. And let me just say that we, as a robotics community, are privileged to have such an amazing researcher, amazing leader, and just a wonderful human being. So with that, please welcome Dr. Howard to the stage.
That was sweet. Oops. All right, so what I want to do with this time that I have with you is really talk to you about robotics and the research that I have, but with a bent toward the responsibility we have as roboticists, especially as we continue to grow and have an impact in the world. And so many of you know, so Turing, a lot of times we quote the thinking about how do you define intelligence of a machine, and the story, of course, is, is really from the lens of the observer. But I want to start calibrating you on a history lesson. So the real experiment from the paper, and you can read the paper, was there was a man and a woman, and basically an interrogator had to decide if it was a woman, the real woman, or was the man really good at mimicking the woman. So that was the test. And then they would take the man out, and they would put in the machine, and they would see, can the machine now pretend like they were a woman to basically fool the interrogator? And if the machine could do it more than the man, that was intelligence. And so when I think about Turing, and I think about AI, and I think about robotics, and I think about some of the things that we're doing in this space, it really isn't about whether the machine is as intelligent as a person from the lens of the observer, but it really is about bias. When we think about robotics, when we're integrating robotics into our society, we are doing it based on our societal biases, and that's a fact. Now, whether that's good or bad, we can argue, but I would say that is what we are really doing. And so when we are looking at this space, one, we have to be honest about this, but it allows us with that honesty to actually make sure that our technology is valid and viable and doesn't have negative outcomes or mitigates the negative outcomes. And so my area of research is in collaborative robotics, which basically means what I want to do is take scenarios where you have two humans that are interacting with the space, and what we want to do is augment that and take out the human and add in a machine, add in a robotic system. And so understanding the biases of humans is actually what I do, so that if I have a human and they're interacting with a machine, it should be as natural as possible. We should understand that aspect of what is it that they're doing, how are they modifying their behaviors, what engages them, because the machine should have the same equivalent experience with the human and the human with the robot. And so that's what we look at. And so I'm going to go through some of the challenges with this, but also some of the observations that we've had with people. And I will tell you, humans are very special creatures. They surprise us in many ways, but we can also be modeled. So one of the things that we know is that when humans are interacting with their machines, they actually go through what we call a cognitive bias. what that means is that when a person is interacting with a robot or an AI system, there is this element of trust. The machine says something, provides guidance, provides information, and the human does actually defer their autonomy, their decision-making power to this machine, more likely than not, rather than with the human, which is an amazing phenomenon because that means that as our machines are interacting with us, even if they bring in their own biases or biases of their developers, biases of us, it means that humans, other humans, user, are more likely to follow the guidance, follow the interaction, just believe. And it's only until later like, oh, why did I do that? Why did I just go through this hospital with my Tesla in autonomous mode? What was I thinking? But the fact is our brains actually disconnect and we start thinking about other things, more complex problems. We think about what do we have to do today because we have this element of trust. And so with that, what we want to look at is what does this mean for the space? So I always start my talks by talking about the positive because I think that when we talk about the negative always, and media kind of does this always, then you have the entire world going like, well, why are you doing robotics anyway? Why are you doing this AI? And so I always start with the positive aspect of the, well, this is actually good for us. So my area of research is in pediatric robotics. We bring robots into the clinics, into the home environments to work with children with special needs, primarily children with motor disabilities, primarily children with cerebral palsy, in order to engage them in rehabilitation exercises. So that's really the gist of my research. And so a little bit of a calibration because I always encourage us to work in these different spaces that might seem niche, but they really are much bigger than we think. In terms of the statistics, currently there's about 240 million children with disabilities worldwide. I will tell you, about 10 years ago when I would show this slide, it was 196. That's not a long time for us to have this increase. But what's actually terrifying to me, because as I get older, I think about this a lot more, is that currently in the US, 1 in 4 US adults live with a disability. And this is before COVID. We're actually, when they do the stats, we anticipate this is going to get larger. And when we think about disabilities for adults, it's everything from mild cognitive impairments, it's losing your eyesight, losing your hearing, so it's a whole category of disabilities. But it basically means if you look at this room here, if you look to the left, you look to the right, you look front and you look back, one of you is going to acquire a disability or has a disability. And so if you're thinking about your research and you're thinking about doing things in robotics and AI, you should always think about this world of those who need access, because you will be a statistic at one point. And so I always promote, say, think about it, think about it, think about it, because when you're 80, you might want to go like, wow, I really should have worked on that one problem back when I was 25. And so this is a middle motivation that, yes, you do. So this is the statistics. I work, again, primarily with children with special needs. And so what that involves is going into the clinic session, going into the homes, working with parents and clinicians, doctors, therapists, and really understanding how they interact with children. Because again, what we're doing is taking that person, we need to augment. And so we need to bring in the child, machine, the robotic system, interacting. And so we want that to be seamless because because this is exercise, the child is working with a clinician in the clinical setting. When the child goes home, those type of exercise, those type of interactions should be very much the same, equivalent, because that allows us to increase the number of sessions, increase the contact, doing one very specific thing. And so we don't want to have the robot do something totally different because then you do not get the kind of outcomes that you need, the repetition, repetition, repetition. And so we look at this, we model this, and we continue doing this. And what that means is that we influence their behavior.
Here we go. You can do better. Okay.
Okay, so if you notice, there was you can do better. So what we've found is that when we design robotic systems, when we bring this into the environment, we are influencing the children's behavior. In certain cases, we are manipulating the children's behavior. And this is actually, for us, it's like, this is good. This is what we kind of want. I mean, this is what humans do with other humans all the time. You go into a lecture, the professor is guiding you. The professor says, well, the final is worth 80% of your grade. The rest of the assignments I really want you to do, but it's only worth 20%. Your professor has just manipulated your behavior. Because what are you going to do? Oh my gosh, the final is worth 80% of the grade. I'm going to make sure that I do everything in my power to pass that final. We do this as humans all the time, and what we're doing with the robotics is we are manipulating, influencing is a better term, a child's behavior. But what happens is that at the end, parents are ecstatic, clinicians are ecstatic, because with that manipulation, with that influencing, we improve outcomes. So I always like to show this study. This is one of our first studies. And I like to show it just because it was the first time we had done a fairly long, so in my world, 8 weeks is long term, a fairly long-term study where we were able to show an impact of robotics as an engineer. And so I always show, you always remember your first time. So this was our first really like, oh my gosh, as engineers, as roboticists, we can have an impact on others' lives. And these are people that are not paying me. So this is really a good thing. And so just in general, what we wanted to show was that when children were without the robot, there was a normative function, their normal behavior, how they interact. So we look at range of motion, speed, movement time, and those aspects. Then when the robot is there, so this one shows we want the child to move faster. So you want to increase their time, their speed, their velocity profiles. With the robots there, basically he's saying, hey, I think you can move a little faster. I know this is hard. Like that kind of motivation, what we can do is we're pushing the children to actually exert themselves. And then when the robot is disengaged, what we see is that there's a decrease with the robot. And so we can go into what this does and what we think about the ethics, and there's things that we think about when you disengage the robot, then we're now having this reliance on our technology. But what it also says is that when the robot is there, definitely influencing behavior, guaranteed. The other thing is that we know when the robot is there, there's this element of trust, increased trust, and I'm not going to go much into that. But one of the things that we have seen is that outcomes between humans and robots is equivalent. I've tried and tried and tried to show that robots are better than clinicians. I have tried, trust me, have not been able to show that. But what I have shown is that when children are interacting with robots, when adults are interacting with robots, they have more self-efficacy, they have more enjoyment, they have more autonomy, or they think they do, than when they're working with person. Even though the outcomes we look, they're improving in terms of their milestones, which is interesting. And so given that, what we want to do is then look at, given that we manipulate our influence, are there conditions around which we should be doing this? We need to ask these questions just because we can, and we know we can do a lot of stuff, just because we can, really should we? And what are the scenarios and what are those situations where we have good outcomes, healthcare? We can say that's a positive, but how far should we push that? And we need to really ask this question as roboticists so that we can have this conversation, especially when we talk about societal impact and them understanding what it is that we do. So we have, and I want to just show the one video because this really shows the kind of engagement that we have. We typically use humanoid robots with this, but I want to show this one.
Hi, my name is Pepper and I am a humanoid robot. I am able to perform a variety of different occupations. I can also assist people with lots of daily tasks. I also have the ability to tell lies when I believe it is in your best interest to do so. For example, if you ask me if you look good in a certain outfit, I may choose to say yes even if I do not think you look good.
So, deception. When we think about manipulation, we can cast it out as a form of deception. We don't usually use that word lies. We don't usually use the word deception. But again, I think this is this thing about owning the space. We are influencing human behavior. We are manipulating it. We are lying. These robots don't have emotions. We're programming the emotions. We're programming the behaviors. We're looking at how humans and humans interact. And then we are trying to get people to believe that it's of the robot. The robot is learning new knowledge. No, the robot is learning between humans and humans. And so I think a lot of times when we shy away from robots are lying, robots are manipulating, but the fact is that's what we're doing. And so we need to own the space so that we can have a conversation about the boundary conditions. So I want to show you a couple of stories of how this comes out and the positives as well as the negatives of this. So given this kind of scenario, so the scenario I just showed you, this interaction, we repeat it for different tasks, different information, and so just wanted to show you that one of how we're doing it. And so when we do things and we ask certain questions, we look at behaviors and we look at outcomes, I want to share some of the interesting findings that we have. So when we have different scenarios between humans and child versus robots and child, for example, in healthcare domain, education, for older adults, same thing. For typical adults, we'll have different scenarios like helping with the job. When we ask individuals, is it appropriate? So is it appropriate for a robot to deceive or manipulate or influence a child or an adult or an older adult? What does that mean? And then compare it to a baseline, because we want to compare it to a norm, which is humans. And so in a lot of cases, you'll see at the top line, there's this aspect of, for children and older adults, it's really not appropriate to have a robot manipulate and influence. It's just not appropriate. But for an adult, yeah, robots can manipulate us all the time. We are fine with that as compared to the human. We do not like other people lying or deceiving or manipulating us, but for a robot, it's okay. But when we're looking at older adults and children, it's like, no, that just feels wrong. And yet, when you ask about, well, but does it make sense? It's like, yeah, of course it makes sense, because older adults and children, vulnerable, of course it makes sense. We don't feel comfortable with it, but of course do it, because it just makes sense. And so if you think about this, it means that there's something about a robot coming in, especially in the healthcare domain, interacting, that, yeah, people may not really like it, but they will accept it. Which again, if you think about it, that's kind of interesting, kind of strange. And we've had a bunch of studies where we look at behaviors and how it changes, whether it's a child or an adult, or we haven't got to the older adults. But the fact is that this information is actually present as well when you have people interact in different scenarios. The other thing is, when we look at, and this is I always have to, most of you who are in this robotics space, I know a lot of times you're always asked about, well, does the embodiment really matter? Can't you do everything in the virtual? Isn't it the same thing? And so a lot of times in my studies, we try to ask that question, because in some cases we can say, well, virtual has just as much impact as the robotic system, and we publish that in the AI literature and not in the robotics. When we get the reverse, we put it in the robotics literature and not in the AI. We kind of manipulate the system that way. So we wanted to see, well, what happens really when humans are in this space of interacting with the robot. They know it makes sense in certain cases. They really don't like it. Does that change if you're, say, working with a chatbot or a virtual agent versus a physical? Is there something magic about physical? Because again, these are questions. Most of our applications, as you know, that are out there are still in the virtual space. We have not got to the point yet where we are interacting with robots in a day-to-day interaction. But in terms of the AI virtual, we are interacting on a day-to-day space. And so thinking about, is there a difference when we're thinking about deception, when we're thinking about lies? And what we found, and we have a number of kind of outputs, but what we found when we look at the virtual and we look at the physical, there is a difference, which is amazing. And so just kind of helpful honesty, harmful honesty, it's if I am doing something and I'm interacting with you, if I'm telling the truth, even if it harms you, like, yeah, you're about to go crash and die, I just wanted to let you know, versus deceiving, no, it's okay, just close your eyes, everything's going to be fine. So that's being dishonest. When you are honest, whether it harms you or helps you, there's this aspect of trust, and the robot makes a mistake. But if you are dishonest, if you are deceptive, your trust decreases. But if you are in the virtual, it's even more impactful. I.e., if you are a human working with a robotic system and they do something wrong, they make a mistake, they lie, you're going to still interact with the robot. You're still going to use it if it has a physical embodiment, which actually says that as we think about our robotics, as we're pushing them out into the space, as we're designing, realizing that with the embodiment, especially when you have these scenarios where the robot is deceiving and manipulating, just by having the physical, it's going to have a larger impact on their behavior. which in some cases a roboticist terrifies me because the virtual space, I mean, they still haven't figured out the bias and the ethics of this. And so unless we really think about this intentionally before we have robots deployed, we may be in a worst case scenario because we will have even more of an impact in terms of changing behavior than in the virtual space. So we know robots can improve our quality of life. I wouldn't be a roboticist if that was not the case. And we know that people interact, they trust these systems, they push forward, and they do it. And so I want to say, so what's the problem? I'm a roboticist. I've been doing this for more years than I can count. I love the fact that robotics and AI is like so popular. It's like if I could turn the crystal ball, like I knew this was going to happen. That's why I chose it. And of course, none of us actually knew that less than 50% of the individuals who have been doing this forever had no idea that this would be so popular. Like we would be the cool kids now. Had no idea. But when we think about the problem, we have to think about the what's next. And so I'm going to talk about the biases. I talked about the cognitive bias, but the fact is when we are mimicking human-human interactions and influencing human behavior, we are taking on the biases of the human that we are mimicking, and that is a fact. And the fact is that when we think about biases, bias is not always negative. Bias is actually a survival mechanism that allows us to survive. It allows us to learn. It allows us not to get eaten up by the dinosaurs and the snakes, right? That's what it allows us to do. But what we've done is we have taken these biases, and as we interact with other humans, they also influence our beliefs, they influence our behaviors. And therefore, our robots also have that. So this is good in some aspects because of the cognitive bias. It means humans will trust my robots, most likely than not. But it also has a negative if the type of behaviors that are coming out are biased toward different demographics, biased toward children. I work with children. I will tell you there's not a lot of data sets of children on the web, and therefore all of the open source software that you grab and download, it does not work with my kids, right? And so these biases are definitely present, and yet these tools are there. So, emotions, I mentioned that we think about the emotional state, and we can talk about emotion, facial recognition, but emotions is a human characteristic. Part of the way we manipulate people is we try to identify their emotional state, and we lean into that. So if we know that they're happy, we're like, okay, we're going to do more of this because you're more likely to engage. If we feel like you're turned off or disengaged or unhappy, it's like, okay, don't do that. That's probably not good. Let's get them to the happy state. And so that's a way of manipulating behaviors. And so when we think about healthcare, we also know that your emotional state will help dictate your outcomes. If you go into a hospital or a child is working with a clinician, if they come in and they are happy, they're pleased, they're even in a neutral state, they are more likely to follow the guidance of the clinician, whether it's human or robot. If they come in grumpy, if they come in because they just got an F on their homework, if they come in with that type of attitude, they just don't do better, even though they're still moving. And so this is a fact. And so with robotics, we also want to identify and follow and know what their emotional state is so we can adapt the robot behavior to engage. But we also know, again, working with children, and the other extreme, I mentioned older adults, that the systems that are out there that are deployed in our world, in our society, they have biases, and they have biases with respect to children as well as older adults. And so that 1 in 4 I mentioned, the US population, and anyone here who is getting to 50, 60, 65, these systems don't work for you. So you might want to go ask your students to start working on this. So the outcomes are different, and we've been tracking this. So we have studies from starting about 4 years ago. Every year we track how these systems are doing that are out there, both the open sources, the commercial, to see have they improved. And they have improved on things like gender. They have improved on things like race and ethnicity. They have improved in certain categories. They have not improved with respect to this age demographic, and I think it's because you just don't think about age. And if I look at disability, it seems to even decline when we look at disability aspects. And so this is a space where we have AI companies that are deploying, and this can seep into our robotic technology time and time again. But one of the things is, not only in my group do we talk about these aspects and say, okay, here it is, here's the negative outcomes, but we also, as a roboticist, we have the tools, we have the skills to actually develop solutions to solve it. So in my group, not only do we recognize, quantify it, but also develop the tools to figure it out. And so when they say, oh, we can't do this, there's not enough data, it's like, oh, you just give us another grant and we can show you how to do it because we've done it before. And so even with emotion detection, facial recognition, we have shown, and this is just an example, where you can take what's already out there, and if you're intentional about adding things, adding scaffolds, adding ways in terms of a pipeline and hierarchy, you can take things that are already out there being deployed, wrap it around, and it actually works for certain target demographics. We've done this with older adults, we've done it with kids, we've done it across race, gender, and intersectionality, which I won't talk about right now, but intersectionality is also a thing, which means you belong to 2 classes, which all of you do because you have age, you have race, ethnicity, you have gender, and you have religion, you have ability. So think about the intersection of those. None of these systems work at the intersection equally across the demographics. So that's it. The other thing, and I think I have about 15 more minutes. Yes? Okay. I want to talk about a couple of things that I think as roboticists we should just stop doing. So one of the things, we tend to like to add gender to our robotic systems, our AI systems. We do it too. Like, I have names for my robots, and I have voices that I identify, and so I choose as a researcher to have a gender for my robots. We all do if you're in the humanoid space and you're in the assistive robotics space. And research has shown is that when the gender matches your expectations of function, you actually, quote unquote, trust it more, and when there's a mismatch, you don't. As an example, if I have a human doctor that comes in, if they're a female human doctor versus a male human doctor, you are more likely to believe the male doctor. It's just a fact. Same thing goes for nurses. If a nurse comes in that's a male nurse versus a female, the male nurse is like, are you a nurse? Are you sure? Where did you go to school? Right? So this is what we do because we have an expectation. So what we wanted to see was, well, does this apply to robotic systems? As robots are deploying more and more in our society, as they take on these functional roles, does this gender have a role? And so if it does, based on some of this aspect, it means that we should have this gender. And so this makes sense. Like, yeah, my robots all have gender, and they're female because I do assistive robotics, right? That would make sense. And so we just want to validate that this was true. So we presented different robots, male robots, female robots, neutral robot, and we did a prior study to actually get the names and the voices right. And so we knew that, female, we gendered it as female. Did people recognize it as female, male, and neutral? So we did that as before we deployed it based on the function to make sure that it wasn't our interpretation that this was a female robot or a male robot or a neutral. And interesting enough, when we did the evaluation first, when looking at this function, trying to look at the mismatch and trying to really validate that we do need to have gender on our robots for certain roles, that was actually the hypothesis. And when we looked at the male robot, we got it right. People who identified the male robot that we had intentionally gendered as male, gendered as female. Interesting enough, when we had our neutral robot, interesting was that most individual gendered it as male. It had no name, it had no pronouns, it had a neutral voice, and we had a neutral voice because in the prior, we had it, like, this is the neutral voice. People recognize this as neutral, but as soon as we put it in the scenario where it had a function, most individuals, when we did not prime the gender, actually thought of it as a male. When we asked them, does it have, we provided them the option to say it had no gender. Which then was, well, first off, this was going to ruin the hypothesis, and it did. But what it meant was that when people are interacting with robots, this is this cognitive bias aspect, that when they think about robotics, they think about function, they think about technology. And therefore, if we're not priming the person, they think of the robot as male. Which, of course, we're like, okay, so what does that mean with our robot nurse? Like, is it male? Is it female? Okay, again, our hypothesis is totally wrong. That's kind of the byline of that. And so when we looked at different roles, we actually didn't know. It was one of these things like, I don't know if we can get a paper. Maybe we can get like one of those 2-page workshop papers out of this. We said we did it. We published something. What we found was that there was no difference. People followed the guidance. People actually had trust. People believed in the competency, irrespective of the gender, which says that and this is even for the case where we had neutral and they gendered it male, which says that when people are interacting with robotic systems, when we add gender to it, we are, again, putting our own biases on them. People will gender the robot. They will gender it based on what they're comfortable or what their expected functions are, what they believe this robot should do. Bus driver, I'm going to gender it as one thing if it has nothing. And therefore, I've always pushed back now, even on my group, is why are we putting our own biases in these robotic systems by trying to add a gender, trying to add voices, trying to add a name, when people will do it themselves? And let's give them the autonomy, and let's give them the power, the user the power, to actually have their own biases, which actually is a good thing, because bias is a survival mechanism. And so if I give you the power to extract and interact with the robotics based on your own biases, we as developers are not influencing the fields, influencing society based on what we think is right. And so that's a little bit hard, because I actually like the names of my robots. I like doing voices. In fact, my students have a ton of fun, like, oh, what about this voice? And what about this octave, right? Like, that's actually a fun part of the research. But I push back to say, let's try as much as possible to not add in our own developer biases to these systems, because people should be given the autonomy to survive and live and thrive based on their own. And so thinking about this and trying to push this is like, well, can we use this aspect of people adding their own bias, people interacting with robots? Can we use this then to possibly be a solution to this aspect of this gender issue that many of us do? So we had a task, and this is the last one I'm going to talk about, where we had a robot provide guidance, provide information to coding, basically people who labeled, who codified the data. We looked at emotions. And so we looked at our emotion data sets. We chose emotions that were difficult, that in terms of iter ratings, i.e. people found it difficult to classify these emotions. So there's different data sets where it's like, oh, only 60% of the people agreed. So we chose emotions that were a lot harder to recognize, because we wanted the robot to be there as a guidance factor, like, oh, here is the emotion, you can believe me or not. So that's what we wanted to do. And we were looking at gender, again, gender, race, ethnicity, but the one I'm going to talk about is gender. And we wanted to see, can we use this aspect of the mismatch, this aspect of adding gender or biasing it to maybe influence you to do better in the coding in terms of trust. And so these are some of the images in terms of the uncertainty. So uncertainty were those that were difficult to classify. They didn't have a lot of agreement in terms of coders beforehand. Uncertainty are like, these are obvious, like everyone agrees that this is anger, this is happy, this is frustrated, this is sad. And this is our data set. Then we sent this out to different coders. We're looking at the difference in male. And what we found was that, interesting enough, when there was a gender mismatch, i.e. if I had an individual and I was trying to classify someone who was not my gender, recognized gender, so female, and I was classifying a male image and they were uncertain, I would actually have higher levels of trust in the robotic agent, because the robot is telling me, like, oh, this is this class, I'm just giving you some information. I would actually, more likely than not, say, oh, okay, I'm going to go with the suggestions from this person. If it was a gender alignment, gender match, I more likely was, no, the robot doesn't know what it's doing. Clearly, that's a happy face. And think about it, it's because I recognize this aspect of bias. I'm looking at my face every day. I'm looking at others that are in my in-group a lot more often. So I'm just trained more so to recognize someone who's female and their emotions, right? That's kind of the in-group. I'm not so well trained of recognizing male faces, because that's not my gender in-group. And therefore, if I have an agent that I'm already have this cognitive bias toward that tells me, well, this is how you should classify this. And I'm like, well, I'm uncertain. I believe you more so than not. I'm going to go with you. And so why is this important? Why it's important is that if we can get it right with the AI, if we can get it right with the robotic system, it can also train us to be less biased. And so we've actually been able to show that after we do this a couple of times, we can actually get individuals to improve their ability to recognize emotions in their outgroup, which says that this is a positive way of using AI and robotics, to actually use it to help us mitigate our own biases and autocorrect ourselves. And so these are the kind of the things that we think about of how is it that we as roboticists and AI are, again, suddenly become popular. What are we supposed to do? We always say, well, it's really not our fault. People are biased. They're taking our robots. They're using it. Why should we even care? But the fact is, I think that we are the ones that have to care. We are the ones that are designing, developing, and making this technology and deploying it. And so it is in our best interest to actually do this correctly and do this right. And I think there is hope, because if you look at the aspects of AI ethics, robotics, looking at bias, there is an increase in interest in this. And it's not necessarily because of us, it's because the world is asking for it. And as good researchers, you kind of go with where the funding is, and you go with where you can publish, and you can go with all these things. And so there is some external pressure of doing this, but it makes me hopeful that I see more and more researchers that traditionally would not even think about ethics, that are moving into the space and are thinking about it in their communities, and thinking about, okay, I'm going to publish my data sets and actually say what the demographics are and actually publish it and provide it as a resource versus just having, well, here's my data set, figure out it for yourself. I'm not going to give you any labeling for it. I'm hopeful that we're actually moving into this space. I think the focus on people, I think the focus on diversity, and when I say that and when I say people, as roboticists, we really need to think about what the impact is when we are deploying these systems out there. I know we aren't necessarily trained as social scientists. I know we're not necessarily trained as thinking about the ethics of our research and our technology. But the fact is, especially for those who are students, this is just going to accelerate. This is just going to continue to grow. And I will tell you, in 2020, people would say, well, when would robotics actually be deployed in society, healthcare robotics, like when would it be used? And all of a sudden I'm like, where are all these companies? And they're actually deploying these systems in hospitals and in clinics and getting paid for it. It's not just about research. And so there's going to be an acceleration of the physical embodiment of the system, as well, of course, as we know, as the AI. And therefore, if you think about our role as roboticists, we really do need to ensure that as we're doing the research, as we're pushing forward this field, that we're also thinking about the ethics of people and weaved in, and that we are definitely this aspect of diversity. 95 countries are represented. And so that is an element of diversity, which means that when you're working in this research, when you're working on this technology, you are also, I'm going to say, it is your responsibility to also bring your whole self to this. Whatever your gender, whatever your nationality, whatever of your country of origin, bringing your whole self to the problem is really the only way that we can solve all the aspects of bias and kind of the deception, ethics, and things like that. And so with that, it is our responsibility. I truly believe it. We have 7,000 plus individuals, including in the virtual space. I think this is the team, I think this is the group that can actually do it. And I am hopeful, and I am hoping that when I'm 80, 1 in 4 US is probably going to be closer to 1 in 3 in a couple of years, that we are the group that actually makes it so that when I'm 80, I don't have to worry about it. And so with that, I want to say thank you, and we will open up for questions.
Thank you for that awesome talk. So we have time for Q&A. There are 2 microphones there, and I can't really see, but somewhere over there, I think. Yes, over there. We also have, for people who are online, if you want to put things in the chat, I am looking at the chat, if you have any questions for Dr. Howard. Yeah, please. I don't know if, go ahead.
Hi, I'm Kalvik Jakala from the University of North Carolina, Charlotte. That was a fantastic presentation. Thank you for that. And I have a question, which is, if we build robots that are neutral, gender neutral, do you think we are enforcing unhealthy gender biases in people? And if we are, do you think it's our responsibility to try and correct such biases?
Yeah, so I think we should this aspect of gender neutral. I think as roboticists, we should basically have gender neutral because even now, the concept of gender has changed and evolved, right? We traditionally think about gender in the classical female and male, but that is no longer the case. And yet, as roboticists, we haven't really even discussed what that means. And when we think, therefore, of gender neutral, that is the closest we can get to basically saying, look, there are different aspects and elements of gender. Let the individual decide the gender of the robot, because they will. That's the whole thing, is they'll interact and they'll say, oh, this is a he, this is a she, what are the pronouns? Like, let's give the autonomy versus us. And so gender neutral, that aspect of not imposing gender, I think is one of the things that's good, because the role of gender is evolving, which means that even in 5 years, there's going to be other pronouns, and therefore we need to have that flexibility in the world. Because we, as roboticists, we're not even talking about this element of gender and the differences that our society has really pushed forward. Thank you for that question.
Yeah, thank you.
Have we got the side?
Hi, Professor Howard. I'm Shreyas from Stanford. I really liked your talk very much because one of the things you made accessible is something that I think we often have a fragility response to. We as roboticists, like you said, are not trained to think about gender, race, or biases, and we feel maybe even attacked when we start hearing about these, but you made it super, super accessible. And something I've been working on recently is how do you get people to talk to each other and start to recognize their biases and deal with that discomfort? But I had never thought about potentially using robots for it. So you have this possibility, this idea of mitigating bias through robotics, shown through gender, but I wanted to know better, what are the challenges you see going to other biases and even towards intersectionality, as you mentioned, is a key challenge?
Yeah, so I think the challenges are the fact that we don't have all the representation in the room. And so you probably don't want me to talk about the male concept, right? Like if it's a team of females and we're designing, yeah, what do we think males should, what do they like? I mean, and that's what we do for the other aspects of diversity. And so I think it's really important to try to figure out a representative from, I mean, and they're not gonna speak for the whole X, but just having someone that can ask the questions. Someone that says, oh, you know, age, like older adults. So bringing someone who is at that 70, 80-year-old age that says, oh, you know, there are some things that we think about in this space. I think that's the way. I don't think we should make up stuff for the different groups, especially the intersectionality. What I think is that we should bring in everyone so that they can at least connect with their in-groups and bring that information to us.
That side?
Hi, absolutely incredible talk. You mentioned children feeling more autonomy when working with a robot than a human, and also mentioned people sort of projecting their own biases onto robots. I was wondering if you think people tend to view robots more like separate agents or more like extensions of themselves, or what scenarios you feel like people do one or the other.
Yeah, so believe it or not, individuals, they treat robots as their in-group, which is fascinating. So it's basically an extension of their community. And therefore, when children are interacting with a human clinician, that's their out-group, right? That's an adult. They're telling me what to do. When a child is working with a robot, that's my in-group, that's my friend, that's my playmate. Even though the functions and the commands are exactly the same. And so that aspect of this in-group is you have more trust, you feel more autonomous, you feel like they understand you more. And that's really the element of the in-group versus out-group with robotics. Thank you.
Hi, Professor Howard. My name is Lavanya. I've been a huge fan of your research for a long time, so thank you for this talk. So the question I have is actually, do you think robots could be used to help train humans to have less harmful biases and sort of help us create a more equitable society? The reason I ask is, if there's a general tendency of humans to trust robots more, they might be more receptive to that training from a robot than from other humans. I mean, typically you get a knee-jerk reaction when you're trying to talk to somebody and trying to point out a bias. So do you think that would be useful?
Yes, in fact, there's some preliminary research, some in my group, but some in others, that have shown that you can use robotics and virtual agents in another case to help people have an empathy for other groups, which is fascinating. They're using it in some cases for the military when you have some of the soldiers going into areas of conflict of, okay, how do you have empathy for the group that's present there so that the soldiers behave a little bit more appropriately. So it does work, and it has more impact than, say, a commander-in-chief saying, you got to figure it out, you got to suck it up. Having a robot or AI agent, you are more likely to try to work on what they're teaching and not be offended, not have that knee-jerk reaction of, oh, you're trying to change me. And so I would love to see more of that kind of research where you're using the manipulation function for aspects of good. We don't do enough of that, but I would love to see more research in that domain area. Thank you.
Thank you for the inspiring talk. My name is Afaf, and I have a kind of a repetitive question, which I would like to have a deeper insight from you on. So you did mention that children tend to trust the robots more than humans, and they also tend to have more learning efficacy in the presence of a robot, right? I was interested in the why behind it, And another point is, have we, as parents or as people who raise children, somehow failed at, gaining that trust from children, like a robot does? What's so different about a robot than a human being? And the second part is, what can we learn from these robots that help children or assist children to learn? So what can we learn about raising children from these robots? Because a friend of mine once said, and I truly believe in it, is that once we are interacting with children, once we are raising children or interacting with them, it's time to learn about life all over again. So I really believe in it. So maybe perhaps you could shed a light on this.
Yes, for any of you who have children, when you have children or you interact with children, you realize how stupid our robots really are. But one of the things about working with a robot, the learning outcomes aren't different. So it's not that robots, our children are learning better or learning more. It's equivalent. The problem is that when you have a human working with a child, their modes, their interaction changes enough. Right? So there is actually some nuance, there's some standard deviation around some normative function, but it's still a standard deviation. With the robotic system, it's pretty much like the standard deviation is almost nil. I mean, it's sensor errors. That's really what the standard deviation. So it's much more repetitive. And because of that, I think when you think about the child, one is they can predict the function, so they can predict the behavior, they can predict the emotional state. They like that because now they are casting their behaviors based on the expected outcomes of the robot, and it becomes this really tight feedback loop, which says that as a child, I'm in control of this. I can do, and I will tell you, sometimes the children do really weird stuff just because they want to see what the robot does, like, oh, let's do something different. And the robot reacts in whatever the programming language is, but it reacts. Whereas the human clinician will be like, stop it, that's not the session, I need you to stay on task. Even that slight aspect of the human putting in their own emotional state into the situation actually changes that aspects of trust and behavior. And so that's what it is because the machine is a machine that's coded and personalized to the child. And therefore, there's much more of a closer interaction, closer feedback loop with the machine.
Oh,
thank you.
So I'm going to just take one question. I'm going to take one question online. We as humans disvalue other humans with the feelings of grudges for them, ego, and hard feelings. In the future, paraphrasing, in the future, do you think these emotions would also translate towards more humanoid robots in HRI type of scenarios? I think that this goes back a little bit to also the design question that I wanted to ask and maybe ask you afterwards.
Yeah, so we as people have what's called negative emotions. So disgust, ego, abrasive behavior, these aspects. I don't believe that we should have robots that have our negative emotions, just because if you look at the literature in terms of emotion recognition, negative emotions is actually a learned behavior because of society. The only negative emotion we typically have is an element, and they don't even call it disgust, but it's basically survival. You have a child eat something, they spit it out like disgust, it's because their body is reacting. That is really the only negative emotion. Everything else, like crying is because I want, I desire, happiness is because this is a positive aspect, I want more of this. But things such as ego, things such as true contempt, is learned because of our interaction with other humans. And therefore, because it's really not a natural aspect, we do, at least in my group, do not program robots because that is one of the historical biases that changes based on how you grow up. If you grow up in a loving home or a loving country versus a negative one, you will have more negative emotions. It has nothing to do with nature. It has everything to do with whether you're nurtured correctly.
Okay, thank you. Please.
Hi, my name's Taryn Imamura, and I'm...
Can you speak up?
Oh, is this better? All right, cool. My name's Taryn Imamura, and I'm a PhD student at Carnegie Mellon. So, first of all, excellent talk. I appreciated the communication, the accessibility as someone coming into the field from a different subdiscipline. But I was wondering, robotics as a field is incredibly diverse. Like, for instance, I work on biohybrid micro robots. And so I was wondering, how, as someone who's thought about the ethics of robotics a lot, how can we go start approaching the diverse ethical needs of these emerging technologies given how different each subject and each research discipline in the field is?
So believe it or not, National Academy of Engineers, we just published a report on responsible computing research, which was exactly focused on that. If you're doing what's considered, what we say, fundamental research, maybe it's materials in robotics, maybe it is computations like improving something by 0.5% in terms of compute power. Like, what's the ethics about that? And so one of the things is like, whenever you're doing something, traditionally, there's a North Star. I might be doing these kind of materials because I think that this is a type of robotic materials or flexible that allows you to at some point do medical-based application or devices in terms of autonomy. Like there's usually a North Star. That's the North Star that you need to think about in terms of the ethics, right? And so if you're doing something in this space, if your North Star says, oh, at some point this is going to be an X, Y, Z, or at some point it might be Y, what are the ethical considerations for that? Which will sometimes also inform you what you do in the foundational stages, which is amazing because that means 20 years from now, those choices, you won't be like, oh, this is what we have, sorry. It'll be like, oh, we were intentional about the choices and now it works for different ages, or different genders, or different body types, or different abilities. It's hard though, we're not trained to do this, but thinking about that North Star allows us to at least start retraining our minds to ask the right questions.
Thank you.
Okay, we're going to do two more questions. We're going to do one from there, and then we're going to break. But Dr. Howard is around. I'm just going to, yeah, just please.
Hi, my name is Petra Swissler. I really enjoyed your talk. I started thinking about what gender I would assign my robot, which is distinctly non-humanoid. And I noticed that a lot of the robots you showed today were very human in form. And that got me thinking about R2-D2, a distinctly non-human robot that, at least to me, I perceive R2-D2 as male. I think that, show of hands, who sees R2-D2 as male? Female? You know, and so I started thinking, okay, what if R2-D2, instead of being blue and white, was pink and white? Would that have changed my perception? And so I guess my question is, have you looked at all at the fragility of gender perception and how easy it is to change that?
Yes, it's actually pretty easy. You can do, even just names and representation, you can change the paint color of a robot, such as the blue and pink. You can actually add in, so fingers, if you change just the length of the fingers, it actually changes your view of the gender. So these are very subtle things that changes our perception, but it's because we are at least with the humanoid, but not even just humanoid, so we do self-driving stuff. Even that, it's like what kind of car we choose. It's like, it's a female voice for this car versus a male voice, which is like there's a cognitive mismatch. So we're actually pretty easy to model in the gender space.
Thank you.
Last but not least.
Hello, my name is Corey Knutson. I'm from the University of Minnesota, Twin Cities. And my question is actually kind of similar to the last one, but more focused on how there's companies and research into developing robots that look really like humans, kind of getting past this uncanny valley and like trying to very specifically model what humans like. I was just wondering what your view is on that kind of research and these kind of robots, and whether or not we are imparting our biases in these kind of robots, and what your kind of view is on that.
Yeah, so those are really, I would say, the ultimate in developer bias, because the form factor, the characteristics are the developer bias and nothing. And so as we continue pushing that, we are basically putting in our own perceived notions of what is quote unquote beauty, honestly. And so I'm actually a little anti that. And they've done enough studies to show that functionally, people don't care, right? They want a robot that can function, that can manipulate, that can interact in terms of language understanding. This aspect of, does it look human enough? Do the cheeks actually twitch at the right rate? People actually don't care in terms of the function. And so it's really developer bias, this whole aspect of, I want to push the boundaries of recreating myself, and this is how I'm going to represent that, but it has nothing to do with a positive outcome for us as a society. So, personal viewpoint.
Okay.